So, number 15, is that the one that starts with negative 41a? Okay. Greatest common factor, difference of squares, factors of AC whose sum is B?
Yes.
Well, in order for that to work, you need to have it in descending degree of A. So A squared, A to the first, constant. So I'm going to rewrite it. So this is descending degree of A. Factors of AC whose sum is B. Okay, so 210 whose sum is 41. Looks like it's going to be a negative negative, right? So it has to be a negative times a negative. Why does it have to be a negative times a negative?
So if you add them together, you get
Correct, and product creates a positive. So get your calculator out. This is how I literally do it. 210, I just start, no, 210, that's not right, 210, 35 and 6,
yes.
so yeah. So some of you have already got it faster than me, and that is right, 35 and 6. So rewrite, no, that's awesome. So 35 and 6. I'm going to put 35 here because 35 and 21 are both divisible by 7. So that's going to be minus 35a and minus 6a. Okay? So I came up with 35 and 6 as the factors. Okay so far? Okay. Group, and hope for the best. 7a, 3a minus 5, minus 2, 3a minus 5. Hallelujah. Since 7a and negative 2 are both multiplied by 3a minus 5, you get this. In either order. Is that correct? Yes, hallelujah. Okay, how you guys feeling about that one? So when you have something that is not grouped in decreasing degree of whatever the variable is, and if there's multiple variables, do the one that's earliest in the alphabet. Like if you have A and B, do decreasing degree of A. All right? How about we do 19? Okay. Okay, so 6u squared v minus 11u squared v squared, lost my place, minus 10u squared v cubed. Okay, question I always start with is there a greatest common factor?
Yes.
What is it?
U squared v.
He's right. U squared v comes out, which leaves me with 6 minus 11v minus 10v squared. Am I right so far? Okay. So after I've pulled that out, I am left with this. What can I do now? Factors of AC whose sum is B. So I'm going to go ahead and if you want to rearrange this, you can. But you can really look at this. This is A, this is B, and this is C. So the same technique still works, even though I'm not flipping it around. If you want to flip it, do it. But I'm going to need factors of negative 60, whose sum is negative 11. So 15 and 4. 15 and 4. So I'm going to just separate this here. Remember, this guy is going to join the end of the party. And this guy is going to go over here, 10b squared. So 15 and 4, a negative 15v and a positive 4v. There's the factors, 15 and 4. Okay, there's the factors. Group, and hope for the best. So 2, 3 plus 2v, negative 5v, 3 plus, hallelujah, 2v. Okay, I've got my signs right. So I am going to group the 2 and the negative 5v and 3 plus 2v. All of that gets combined with that u squared v that we threw out. So you should end up with u squared v, 2 minus 5v, 3 plus 2v, in any order. Okay, because factors rearranged still produce the same product. Okay, so I started with greatest common factor, then I did factors of AC whose sum is b. Okay, how are you guys over here? When you see it, it's obvious, but when you don't see it, it's obnoxious. All right. Number 21. So we've got this big mess going on. K times k plus 1, k plus 2, minus, 3k, k plus 1? Okay. Well, what I would do is I would multiply this out, combine like terms, and factor from there. Because you could say to yourself, well, k is by k plus 1, and 3k is by k plus 1. So maybe it's k minus 3k, k plus 1, k plus 2. But that's not true. Because k is by k plus 2, but 3k isn't. Okay, they don't have the exact same factors. So you can't join them together. So if I FOIL this piece, I get k squared plus 3k plus 2, all of that times k, which is going to give me k cubed plus 3k squared plus 2k. And this here is a negative 3k times k, negative 3k squared, negative 3k times 1, negative 3k. Okay, so I've just multiplied all this, distributed, and came up with that value there. All right, like terms. The k squareds disappear. That's handy. That's bizarre. This is k, this and this is a negative k cubed minus k. Okay. You haven't learned this yet, but this is a difference of cubes. No, it's not, because that bottom piece isn't a cube. Sorry, disregard. The last piece isn't a cube. There's one more pattern that you haven't learned yet, but you won't learn it this year. Greatest common factor is k. So now I have k squared minus 1. What does that look like to you?
Perfect square.
Difference?
Difference of squares.
Difference of squares. That's a perfect square, square root of which is 1. That is a perfect square, square root of which is k. So k and 1 go in one parentheses, and another separated by opposite signs bring down the original value, and that should be our answer. Yes, hallelujah. Okay? So there are going to be times when you're going to have to notice that this item minus this item is what we're factoring. Okay, so they weren't the same factors. This k plus 2 isn't duplicated, so I can't just combine the k and the negative 3k. All right, that's 21. 23, 27, 29. Okay, 23. Any questions on 21? All right, well, of course, these will be on the video later. 23. 2u5 minus 7u cubed minus 4u. So greatest common factor looks like u, huh? Let's start there. All right, u, 2u4 minus 7u squared minus 4. Okay. It's not a perfect square anymore because 2 is not a perfect square. So we're going to have to use factors of AC whose sum is B. So factors of 8 whose sum is that. So negative 8 and positive 1. Would you agree? So factors of this whose sum is that, those are the factors. Remember, this u is going to join us at the end of the party. 2u4 and negative 4. I'm going to put the negative 8, it doesn't really matter. I'm going to put the negative 8 here and the positive 1 here, just because the 2 is small. I don't know, I might be wrong, but I'm going to try it. So this one, I'm going to pull u, 2u squared plus 1. Yeah, that ain't right. 2u cubed. Shoot, the variable should be squared, Mrs. Myers. So I didn't track the variable. The variable has to go up. So u squared, 2u squared plus 1. You guys see what I did wrong there? When I did the middle piece, I forgot to attach u squared. I just had it be u. Minus 4, 2u squared plus 1. Okay. Tragedy averted. All right. So now I've got u squared minus 4, both of which being multiplied by 2u squared plus 1. What's that? Difference of squares. It's not a perfect square. Difference of two squares. U plus 2, U minus 2. Nothing you could do with this last piece but bring down my U that I ignored a while ago. Alright? So, factored out the U, established factors of negative 8 whose sum is negative 7, threw those in the middle, corrected my variable, grouped and pulled out, u squared minus 4 times 2u plus 1, 2u squared plus 1, because that was the shared factor. This is the difference of two squares. To factor the difference of two squares, you take the square root of each piece and separate them by a positive and a negative. There's your answer. Wasn't that one fun? 27 and 29. This is one of those ones where you're going to have to group it and find a perfect square. And I see it already. No, I don't. I'm wrong. Maybe I'm wrong. Let's see. I'm going to have to look at it a minute. 3u minus 6v. I don't know. I'm going to rearrange it. Maybe I'm wrong. And make it u squared plus 3u and negative 4v squared minus 6v so that I can group these. I don't know. Maybe I'm wrong. u plus 3 negative 2 negative 2v V. Say again? V plus V minus. Yeah, 2V. Right here? This one needs a 2. The U goes by U plus 3. The negative 2V goes by 2V minus 3. But you can't combine these because they don't share this. So, Let's rearrange it again. Tried by putting my letters together. How about, go ahead.
3 is supposed to be plus, and on all the one that you're solving, like negative 2b, it's 2b.
Okay. Well, now what? Still doesn't do me any good.
Like you just group the whole thing together, so it's u plus 2b plus 3. Since they share the 3.
Well, this is U plus 3. This is 2V plus 3.
Yeah,
So the U and the 2V don't share the same factor.
Like u minus 2b, then u plus 3 plus 2b. So that's what it seemed like they did.
Right, but they didn't group it here. I have it arranged wrong. You can't group it that way here. I mean, yes, that's the correct answer, but just because they both have a 3 doesn't mean I can just join it with, you're saying U minus 2V plus 3 and U plus 2V?
No, u plus 3 plus 2b, like all those, like the ones in parentheses first.
Yeah, we need to rearrange it though so we see it. This one, I think I see it. I'm going to group these two and make them difference of squares and see what happens with that. I'm going to skip that. So U plus 2V.
I think that's correct, because at the end you're supposed to have...
U minus 2V. Over here, I'm going to pull out a 3. 3. There we go. U minus 2V. Awesome. Okay. So, if you just group them as they sit, you end up finding that this and this both share this factor. Okay? So, you combine this with this, U minus 2 plus 3, because they both get multiplied by that. Okay? If at first you don't succeed, try again. I rearranged it thinking I needed to group my letters, but it turned out this difference of squares got us this and this. Pulling out your 3 got us this, which is a shared factor. Shared factor gets listed once. The 2 items that share it get combined. If at first you don't succeed, try again. Last one. 29. Okay. Q squared minus 1 minus 4Q squared minus 4Q. All right, I don't know. This looks like a difference of squares. So I'm going to start with that. P plus 1, P minus 1. Let's see what we end up with. If I pull out a negative 4Q, I end up with Q minus plus 1. Well, that doesn't do me any good. But I do see that if I group my Factors of 4 whose sum is 4. Factors of positive 4 whose sum is 4. 2 and 2, that would work. If I rearrange this mess and make that a perfect square trinomial, it would look like this, because this isn't going to work. P squared minus 4Q squared minus 4Q minus 1. Does everybody see I took this, grouped these together as a perfect square? Now I'm going to factor out my negative, P squared minus, which makes the negative 4Q a positive, which makes the negative a positive, which makes the negative a positive. So, square root of this is 2Q, square root of that is 1, factors, or twice the product of A and B does indeed equal that, being subtracted from the original item. Okay? Now I have a perfect square here and a perfect square here. So it's the difference of 2 squares. The square root of P, or the square root of P squared goes in the first position, plus, minus, the square root of 2Q plus 1 squared goes in the second position, 2Q plus 1, 2Q plus 1. And there's your answer.